Welcome to Mikab Model College online tutorial. We hope at the end of this lesson, you will have acquired the expected learning outcome. Sit down and listen attentively as we introduce your subject teacher.
Welcome back to another mathematics class. I'm Adobazi Abdullahi. Previously, we discussed the laws of indices, and the part of the laws of indices that we discussed are multiplication laws and division laws. And in multiplication law, we said if you are given a raised to the power of x multiply by a raised to the power of y, the result is going to be a raised to the power of x plus y. That one will represent our multiplication law. In the case of division law, whenever you are given a raised to the power of x divided by a raised to the power of y, the result is going to be a raised to the power of x minus y. And today we are going to look at the other laws of indices. We are going to continue from zero law. And the zero law is telling us that 1 million raised to the power of 0 will give us 1. And we do not know how comes about the 1. X raised to the power of 0 is going to give us 1 as well. We do not know how comes about that. 20 raised to the power of 0 is going to be 1. We do not know how comes about that. But in summary, the zero law is telling us that any non-zero value raised to the power of 0 must be equals 1. The proof of that goes thus. If you have 1 million raised to the power of 0, the 0 there still remain as 1 minus 1, and that same 0 will also give us 2 minus 2 minus 2. And if you have 2 minus 2, you are going to arrive at this 0. 3 minus 3 as well will also give us 0, up to the point of having a million minus a million, which will give us 0. For simplicity, we are going to substitute this 1 minus 1 in position of this 0 as the power of this 1 million. And if we must do that, 1 million raised to the power of 0 will now be equals 1 million raised to the power of 1 minus 1. The reason why we must use this 1 minus 1 instead of this 2 minus 2 or 3 minus 3 is for simplicity. So, you will agree with me that the law that is going to be applied here is division law. Because in our division law we said if a raised to the power of x divided by a raised to the power of y, if you are given a raised to the power of x divided by a raised to the power of y, the result is going to be a raised to the power of x minus y. So if you now compare this a raised to the power of x minus y to this 1 million raised to the power of 1 minus 1, the 1 million represent this a in this division law. This first one represents x as the power of this a in division law, and the other one here also represents this y. So this one can be transformed. This 1 million raised to the power of 1 minus 1 can be transformed in this format, as we have the A to be equals 1 million and X equals 1, Y equals 1 as well. So the 1 million will be expressed as 1 million raised to the power of 1 minus 1 equals 1 million divided by 1 million. Without any indication here, this 1 million is still raised to the power of 1, and this one is also raised to the power of 1. If you divide 1 million by 1 million, you are going to have the result to be 1. That is how comes about 1 million to the power, raised to the power of 0 equals 1. So we must apply this zero law in our example. The application of this zero law goes thus. They said we should simplify the following. A, open brackets, 9 raised to the power of 3, close brackets, all raised to the power of 0. The question B is asking us to simplify 81 multiplied by 3 raised to the power of minus 6 times 9. Okay, the solution of the first one goes thus, which is open brackets 9 raised to the power of 3, close bracket, all raised to the power of 0. The solution goes thus. This 9 within these brackets, 9 raised to the power of 3 within the brackets, can be expressed in 3 places, as we have the 3 as the power of this 9. So if you express this 9 in 3 places, you are going to have open brackets 9 times 9 times 9, close brackets, to the power of this 0. So if you multiply 9 by 9, you are going to have 81. 81 multiplied by 9 is going to give us 729. The 729 is still to the power of 0. And we've stated that in zero law that any non-zero value raised to the power of 0 is going to be 1. The solution of the second question goes thus. The expression is given us to be 81 multiplied by 3 raised to the power of minus 6 times 9. We are going to express this 81 to the denomination of 3, and also we express this 9 to the denomination of 3. So if you express this 81 to the denomination of 3, we are going to have 81 equals 3 times 3 times 3 into 4 places. So in short form, it's going to be 3 raised to the power of 4. That is the index form of 81. And this same 9 is equals 3 times 3. And 3 times 3 is still the same thing as 3 raised to the power of 2. That is the index form of this 3 times 3. And in this expression, anywhere you see 81, you put this 3 raised to the power of 4 there. Anywhere you see 9, you put 3 raised to the power of 2 there. So the expression will now be equals 3 raised to the power of 4 times 3 raised to the power of minus 6 times 3 raised to the power of 2. If you apply the multiplication law here, you are going to pick one out of these days, and if you pick one out of the three, the connectivity here is multiplication. So we are going to add all the powers. So we are going to have 3 raised to the power of this 4 here, plus, because of this connectivity here, raised to the power of minus 6. The reason why we put this minus 6 in brackets is because of the double sign here, positive and negative. And the next one is going to be this 2. The connectivity there is also multiplication. So you add it to this 4 plus open bracket minus 6 close bracket plus 2. And if you rearrange this one, you are going to have 4 plus 2. And if you open this bracket, you are going to multiply this positive by negative here. And positive times negative will give us negative. That is how comes about this minuses here. And 4 plus 2 will give us 6. 6 minus 6, the result is going to be 0. So the result of this 3 raised to the power of 4 plus 2 minus 6 is going to be 3 raised to the power of 0. And we've stated that in 0 law that any non-zero value raised to the power of 0, the result is going to be 1. Therefore, 3 raised to the power of 0 will give us 1. That is the solution of the second question. Now, the other law of indices that we must look at this minute is reciprocal law. And this reciprocal law is telling us that if you are given a raised to the power of minus x, the result is going to be 1 all over a raised to the power of x. We do not know how comes about this. So the proof of this law goes thus. This a raised to the power of minus x, you should note that this minus x is still the same thing as 0 minus x. And this 0 minus x will give us minus x, which is this minus x as the power of this a. And if you must replace this 0 minus x in this position of minus x as the power of a, the expression of a raised to the power of minus x will now be equals a raised to the power of 0 minus x. And the division law is telling us that if you have this a raised to the power of 0 minus x, which is the summary of our division law, and we can transform this to the expression if you compare this a to this a in division law, and this 0 will now be equals this x. This x here will be equals y. So we can transform this a raised to the power of 0 minus x in this form, which is a raised to the power of x divided by a raised to the power of y. And if you are going to transform this a raised to the power of 0 minus x, the transformation is going to be a raised to the power of 0 divided by a raised to the power of x. And you agree with me that this division here is still the same thing as this division in this result here. This a raised to the power of 0 is the one that represents this a raised to the power of 0 as the numerator of this expression, which is the fraction here. And this a raised to the power of x is still the one that we have at the denominator here of this fraction. And we've said that earlier that any non-zero value raised to the power of 0, the result is going to be 1. A raised to the power of 0, we are going to have 1. So a raised to the power of 0 over a raised to the power of x, the result is going to be 1 over a raised to the power of x. That is how comes about this reciprocal law that says a raised to the power of minus x, the result is going to be 1 over a raised to the power of x. Let's apply this reciprocal law in our examples. The example goes thus. They said simplify the following. A is asking us to simplify 7 raised to the power of minus 2, and B is asking us to simplify 3 raised to the power of 2 times 1 over 4 open bracket close bracket all raised to the power of minus 1. And the solution of the first question there goes thus. 7 raised to the power of minus 2. And if you compare this one to the expression of that reciprocal law, where we have a raised to the power of minus x equals 1 over a raised to the power of x. The results from here, you'll be having this 7 to be equivalent to this a, these 2 here to be equivalent to this x. And if you now substitute this a to be 7 in this expression, if you put this to be 7 and you put this 2 to be this x, this expression will look the same as this expression of 7 minus 2. And this expression of 7 minus 2 can be transformed to this 1 all over a raised to the power of x, which is going to be 7 raised to the power of minus 2 equals 1 all over 7 raised to the power of 2. And if you express this one in 2 places, this 7 raised to the power of 2 in 2 places, because of this 2 as the power of this 7, we are going to have the result to be 1 all over 7 times 7 at the denominator. 7 times 7 is going to give us 49, and the result of this 7 raised to the power of minus 2 is going to be 1 all over 49. That is the solution of the first question. The solution of the second question goes thus. The second question is given to be 3 raised to the power of 2 times open bracket 1 all over 4 close bracket all raised to the power of minus 1. If you now compare this 1 all over 4 raised to the power of minus 1 to the reciprocal law, where we have a raised to the power of minus x equals 1 over a raised to the power of x. The 1 over 4 within this bracket represents our a. The 1 as the power of this 1 over 4 within the bracket represents our x. So this 1 over 4 can be transformed in the format of this reciprocal law, where we have a raised to the power of minus x equals 1 over a raised to the power of x. Now, in this expression where we have 3 raised to the power of 2 times 1 over 4 all raised to the power of minus 1, the result is going to be 3 raised to the power of 2 times 1 all over this 1 over 4. You agree with me that we said it earlier that 1 over 4 is equals this a. So if you now substitute this 1 over 4 in place of this a, the expression will be alike. And if you are going to take this 1 over 4 at the denominator of this expression to multiplication, this 4 will be coming up while this 1 will be going down. That is, 4 will now take the position of numerator and 1 will take the position of denominator. Therefore, the expression of this 3 raised to the power of 2 times 1 over 1 all over 4 will now be 3 raised to the power of 2 times 4 all over 1. You agree with me that the disappearance of this 1 here is still the same thing as 1 times this 4, and 1 multiplied by 4 will still give us 4. Therefore, this expression where we have 3 raised to the power of 2, 3 raised to the power of 2 is still the same thing as 9. And this 9 multiplied by 4, we now have 36 as the result. That is the solution of the second question in reciprocal law. Thanks for today. We shall meet again.